Okay, hello everyone. This is session 4. Let's continue with the documentation. This is gonna take around 40-45 minutes. This session is gonna decide what we are gonna implement in the service. So for the last session, we end up here, and then we are gonna do this. So let's start with the persistence layer. Depending on the requirements, we can use one layer or another. So there usually are different kind of like persistency that we can use. One is storing in a data structure inside the code. This has the guns that if the service is restarted, then all information is gone because we don't persist it. So there is no persistency. Persistence is volatile. There is another option which is using a database. The database can be used. There is two kind of databases. Well, actually three. A graph database, but I don't think it's not used anymore. So one is like relational databases and non-relational databases, non-SQL. Depending on the data, I usually use one over another. So especially if I don't have like too many, I have a lot of uncertainty, I usually try to use NoSQL. If I have some kind of like idea of what the user's case is gonna be, I usually use this kind of like relational database, especially if the queries, because with the relational databases, all the constraints in the data are already built inside the database. The relationships and the constraints about if there are fields that have to be unique. And the versioning usually is just very well supported for if there is a new version of the schema of the database. The migration usually is seamless if we use an ORM. If we use NoSQL, the experience that I have using Mongo and using DynamoDB is that I have to build in for Python. I haven't used it for Java or other framework or other language migration tool. So I only have experience with Python for NoSQLs. I have to write a lot of code for versioning. That if I use non-relational database, that is hands-off. I already have it. So in order to know if we need to have a persistent layer, let's go to the requirements. So let's go to the requirements. The requirements are in the test task. So what's gonna say about the data? The data that says like there is a session, okay, cool. There are images up to 5 per session, cool. Okay, and create a face encoding for every, okay, and then summary. So this is the data. Yes, and here it says something like the summary must be available for us to insert anytime. What does it mean anytime? It means that if the service is down, then it can be consulted, or it means that you basically don't need to create. I mean, like it basically is that while it's running, then it have to be consulted. Not clear for me. Maybe I should ask Veriff what it means. But since performance is the key factor, I will say that adding a database, it's something that adds a little bit of overhead. So it means that if the performance is the key factor, then I prefer to start using the simple approach, which is to build a data structure, probably a map inside the application, instead of just basically relying on a database, because it adds a little bit of overhead. How is it to maintain the standard solution? It doesn't say anything about the persistent, but if we want to extend, maybe the solution is not adding just a data structure and use it, but encapsulate this into a particular class to persistent. So let's see how the documentation says in Fast API. So Fast API have this relational database built-in. It's not actually built-in, but it means that it uses this SQL alchemy, and then what it does is to use it as a session local. So it creates, this is for creating the model, creating the model using SQL Alchemy ORM, and then creating the relationship between them, and then down, use it, CRUD utilities. So it uses it. So you have like get users, so you use the DB is imported for the modules, and then query, and then commit, and then for creating, kind of like similar thing. This is like creating. So add, and then commit, and then refresh. To refresh is for invalidating cache. This is created a dependency using yield to have a generator. So it tries to use just only once when this DB is created. This is some kind of like a dependency. Actually, probably this is injected as a dependency somewhere. I haven't checked it, but I think so. Oh shit. Control F, Control V. What is it? Yeah. So yeah, it usually, this is how the dependencies works in Fast API. So it creates something like this, and using this, there is as well a way to create some kind of like annotation dependency. So instead of just using this depend, you can create something like alias. It's easier to use it, but for this example, it's okay. Yeah, it uses the CRUD because to get the database. Okay, yeah, perfect. The CRUD is something that we created. And that's it. Probably, yeah. This is like long example. And then running, wow, that's really long. This is something like really interesting. If you can use dependency with yield, then Python 3.7, you have to use something called middleware, which is a function executing for each request. For the yield, this is really cool in Fast API because it treats, if you use yield as a dependency, it won't create an instance, but it tries to reuse one. So it minimizes the use of the database resources, and then request states. Never use it. Yeah, it actually, well, it gives me well. The same, yeah, that's it. So everything to fast API, yeah, I'm pretty okay, cool. So as I see, there is no need for creating a database, for using a database, because there is nothing to say that has to be persistent. The only thing I say, like, the summary must be available to customers anytime. So the simple approach ever is just using some kind of like entity that can be queried, and then store it as a map. Later, one of the things that we can use is some kind of like cache. So, but actually, if we use a data structure, we can use a cache. Even though right now we can try to leverage to a cache. I'm thinking out loud, but I think that if we start using a cache right now, it's gonna be the same as and then later we can do this kind of like easy to extend, because we use a cache, and then later we can implement the persistent layer if we need to. So I think that there is something about cache here. No, don't look at cache, no. This is completely different. Oh, I thought this was allowed here. Fast API cache. Oh. Error. Okay. That's interesting, because we can use cache and then extend it to never use it, by the way. Redis main cache, or using DynamoDB 3.11, 1 year old. Fast API cache. I thought there was something here, but I completely missed it. Fast API cache. Long Ice. 4 months ago. It was like, this is something that I usually look like 2023, and this is like 4 months ago. I think it's the same project. It's just the same project. Yeah, because I've never used it. I don't know if I can use it for memory. So I can do something like in memory cache expires. When expired, this means you don't access the function after having cached the data will not remove automatically. Okay. So storage in memory and only I think that we need some kind of like in memory backend thing. But I'm gonna ask ChatGPT. Okay, ChatGPT. I'm gonna ask you to. Oh, I was really asking about to run. Okay. Yeah, I will go with it. But I think I have it before using as API or not. Oh, wait, here. Anyway, let's start a new one. So using I'm gonna copy this. So session cache. Okay, so returns the cache and then get tar session, get session. Okay, makes sense. And data cache not never. Yeah, let's do a mat size. But this is a sync cache because I'm looking at this and this is, I think, if I'm correct, this is cache endpoints and function resource with packages supporting this. So, okay, and fast decorator cache. I can use this one. So cache. So get cache. How do you use get cache? Oh, I understand. So yeah, so I'm gonna see the test, but I'm gonna see the examples in memory. So create this pendulum today. So probably this is what we have to do. So namespace session and then return like a session of it. So do we have maximum size? Where is Spire? Give me the, so there is no, this is for time. But there is no size. And I want to basically to avoid to have the storing millions of it. So yeah, that's not. Is this a thing? Yeah. Yeah. With no TTL. Yeah, maybe that's the reason saying like at any time. Okay, yeah, Alario. Yeah, that's recently used. Yes, makes sense. So let's do this. Let's create. Now we have all. So the cache can be stored a maximum size. First one. So let's create an ADR for that. New ADR persist. ADR new, sorry. My brain is fried now. Like 10 o'clock. Okay. So let's ask. Waiting. What the name? Persistent. For managing sessions. and there is, what was the name? And sessions and files in the sessions. Files. And each file can have a facing code. Proposal. And a dictionary. Yeah, performance overhead and complexity. Yeah, and core. Columns, caching validation. Yeah. Yeah, this is something like, if we go to 1 million, what should we do? At the end of the day, it's just dictionaries. Yeah, memory overhead. Yeah, of course, dictionary. But yeah, it's not very scalable. Yeah, a lack of features. Indexing, querying, and caching validation. Yeah, if I evaluated correctly, performance is the key, and then the second is extendability. So we can start with the cache, and then later we can add a layer of persistency. By the way, if we use Redis on main cache, we can persist it too. That's a good point. Um, yeah. And writing more consistently, and what is the next? More concisely, and in markdown format. This is like more concise, very more concise. At the end, I don't care what it says. Actually, whatever I want to say. This is good because actually, like give me another angle for things. I cannot debate with anyone else, so but can be yeah, makes sense. Let's copy and then go in here. Content decision consequences. It's and then let me double check. Why is this like persistency? No. The other CDR doesn't have status context, does it? is the most important criteria. Yeah. No, to reduce. Yeah, I think that's performance bad. I agree. Yeah. Yeah. Moving testing activities. Yeah. Cache, performance. algorithm. Mm. Algorithm cannot be suitable for data. Yeah, the state data. I think catching validation. Attention. Yeah, in distributed environment, catching can be. Catching validation because is the same. Simplicity. Yeah. Memory, generic performance. Yeah, it's simple. I think code readability and simplicity are really tight. Yeah, and I think that it's really simple. But yeah, more suitable for. So install for large data sets, that's correct. Or multiple instances. Oh yeah. Yeah. Well, yeah. hard to stand and extend. Well, and cache can be used in combination. That's your mind. Ya. Vaya tiene ataque. I would say that I think I got it. service. That's it. That's another tick in the box. So that's all. See you in the next section. Bye.